All right, let's begin here by just sort of going right back to the start of vectors and review here. So you know that vectors have a magnitude and direction. You know about the three different types of direction notation. We've talked about those. Hopefully that's all good. We've briefly started talking about vector addition. We did the pirate treasure thing where you learned that what doesn't matter. The order that you add them doesn't matter. That was the number one thing that you should have learned from the pirate thing. And when we do add vectors, how do we place them, Graham? How do we arrange them? What's the special in quote tip to tail or head to tail, right? Just like that. And what's this called here in red? It's not a hypotenuse if it's not a right triangle. Resultant. Yeah. The resultant is the answer to a vector addition question, right? That's like the word sum for a regular addition. Resultant. And this does not have to be tip to tail, right? You always start where? From where you started to where you end, and you always measure the angle from where you start, right? Okay. And you may have to use a ruler and a protractor, like so. Does the order matter? I didn't show you this, and because I spent so much time animating it, I'm going to show it to you now, so I don't waste my time. Watch this. See? This is cool. A, B, C. Where's the resultant? Right there. Oh, there it is. Now what if I put them in order of B plus A plus C? Or I start with C first, I guess. C plus B plus A. What do you get? Exactly the same resultant. Thank you very much. What if I put them in a different order? B plus C plus A. You're right. Exactly the same. In other words, your pirate map, you all should have ended up at exactly the same spot. Okay. Blah, 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 blah. Now, let's talk about adding vectors by Pythagoras. When I say Pythagoras, I forgot to tell you, when I was on a Mediterranean cruise there a few years ago, and we were going past this island, and the captain says, by the way, if anyone's interested, that island over there is the birthplace of Pythagoras. I was the only guy in the boat that was interested. That was kind of
You seem to have those moments a lot.
Yeah, I do, eh? What's up with that? Thank you, Lane. Yeah, great. Does the order matter? No. Okay. Place them tip to tail. If the vectors are perpendicular, what can you use? Pythagoras. Yes. Good old a squared plus b squared equals c squared, right? What if it's not perpendicular? You can't, and that is today's sort of lesson, adding vectors by scale. Now, we did actually do this. Friday was the last time I saw you, right?
Yeah.
We did actually do this. It was kind of near the end. Your brain had probably shut down, right? Yeah. So how about we sort of back up and we'll just go from there. Does that sound okay? A resort of a redo. Okay, so adding vectors by scale any angle. You now have a handout that you can sort of make some notes on if you want. You can only use Pythagoras when the vectors are perpendicular to each other. How important is that? Pretty important. I've mentioned it about 4 times already today. And yet, having mentioned that, there will still be people on the test, quite likely next Wednesday, that will still use Pythagoras when they are not perpendicular. I will shake my head and go, were they not listening? They must be perpendicular to each other. 90 degrees, like north and east or something like that, right? That kind of thing. Vectors that are not perpendicular must be added by using scale diagrams. And the resultant is then found by ruler and protractor, which you must have. And again, you measure with your ruler. From there, right, to the tip of that one. When we do the angle, where do we measure from?
Beginning.
Exactly. So this one here would have to be flipped around. Whoa. Like so. And you must measure in reference to one of the 4 points, either north or east or south or west. You cannot measure from another angle. You must measure from a reference line. So this one here would be like what? About 25 degrees. This would actually be what? That would be east, 25 south, right? Look east, go 25 towards the south. Right? It must be from a reference line. Here's an example. Shall I do this one with you?
Yeah.
You've got it right there, right? Let me see. Does everyone have this handout, even those that wanted to lay here? Okay, so 10 kilometers at north 30 east and 8 kilometers at west 15 north. Job number 1 is make a scale. How can you tell, first of all, that it has to be by scale model and not Pythagoras? Do you know that they're not perpendicular? It's not a 90, right? You got north, 30 east, you got crazy directions, it's not going to be 90. It might be, but not likely. Okay, so north 30 east, and it's always a good idea to draw a little reference, a little sort of sketch here too, right? So north 30 east is like so. Why is it important to do a little sort of sketch first of all? Why do I do that? Not for fun. No one has fun doing this, even me. If I don't have fun, you certainly are not having fun doing it. It's so you know where to draw it on the page, right? Okay, and it allows you to think about it with the details either. So north 30 east, and then west 15 north. So from there we're going to go west, and then we're going to go 15. So where should I start my diagram? Way the heck down here. Way down here. Give yourself lots of room. I need a scale. Your scale always starts with the words 1 centimeter. Repeat after me. Scales always start with 1 centimeter equals.
Scales always start with 1 centimeter.
Yes, and yet there's at least 8 of you that will not do that on the test. I don't know why you don't listen when I say scales must start with 1 centimeter equals. It could be, but it should always be like it should always be what is on the paper and what it's equal to in reality. But it should always be that. And yet I get over and over and over again stuff like 1 kilometer equals 1 centimeter. 1 kilometer of paper is equal to 1 centimeter in real life. It's a pretty big piece of paper. 1 centimeter equals 1 kilometer. Okay, I'm going north 30 east. Get your protractor out. That's a ruler. Right, and we got to go 30 degrees. No, I don't want that. Where's the rotate thing? There we go. Okay, north 30 east. Whoa. Just move. Oh, for crying out loud. So you guys got it much easier than I do. There we go. North 30 east. So to the north, and then 30 degrees to the east, right there. Make a little mark. Get the protractor out of there. Okay, I'm going 10 kilometers, so I got to go 10 centimeters. Okay, so there's my first one. 10, right? This one here, right, Graham? 10? Then what? What do I have to do first? Right, make a reference line. West 15 north. So I'm going to draw a reference line that goes west from there. Does it matter how long that is?
No.
No. West 15 north. Bring in the protractor again. 15 north. 15 degrees north, right there. And I'm going to go 8 centimeters, right? There we go. There's my angle, Amanda. Now what do I draw now? And where do I start the resultant from? From the beginning, way down here. So put your ruler way down here. There we go. And I go right to there. I'm going to put mine in a different, or I'll put mine with the dotted line here. Like so. And you should label that with an R. How do I find out what the answer is? You have to actually measure it. I get like 11.5 centimeters, which is 11.5 kilometers. Again, you can be plus or minus 3 millimeters out. You're a little off. Maybe. I have been wrong before. That was the 70s though. Did anyone else get 11.5?
Yeah.
See? What about my angle? Now here's where the common mistake happens. People will like to do this.
You should probably get a real ruler for
Yeah. People like to do this. What's wrong with this?
That's not, they're not mentioning the rest of the, oh wait.
I'm gonna go 60 degrees.
That's wrong.
Yeah. Why is this wrong?
The reference.
Not going from the reference line. You don't measure from the other vector. You measure from north or south or east or west. Okay? Generally. So it should really be like this. Come on. Give me the rotate thingy. There we go. So put it straight up and down. Put it right there. And I get about 14, 15 degrees, right? So that's going to be north, 15, west. Again, you can be out plus or minus 3 degrees. Okay? With only 2 vectors, you should not be more than out but more than that. Okay? Nice sharp pencil. Put arrowheads on your vectors. It's very doable. It's not impossible.
Why don't you do that for the other?
Because your angle is always, it's got to be north 15 west. So how are you going to say it if you measure it from that one there? You can't say north.
No, like the other corner, not this.
Here?
The other one.
Here.
Yeah.
Why don't you do it from there?
Yeah.
Because you want to know when you're starting out which direction would you head, right? So like if the plane was going this way and the wind blew it this way, what direction would you end up heading? You don't want to know,
I'm sorry.
you want to find the starting direction, yes. Okay, does that make sense? Have I adequately explained how to solve vector problems by scale drawing?
Yeah.
What would be the steps? Make your scale, right? Draw the first vector, draw the second vector, right? Draw your resultant and measure. I guess those would be the sort of the basic steps. After that, there are more details involved. How about you try this one? Try that next one right there, and then I'll come around and I'll see how you're doing.
East, east south, is that where I'm going? Oh. That's the east, 25, south. That's what my.
There's your first vector, looks like that. Is that what you got for the first one?
South.
We're talking south 40 east, right? So there's south,
Oh, I went north 40.
south 40 east, and I have to go 80 kilometers an hour. If 1 centimeter equals 10, then I'm going to go 8 centimeters long.
Hey, so I did my reference line, but I started from the bottom there. Will that change it?
Well, not really. I mean, you're still measuring from south, right? Like, I guess you would just, whoa.
Hot dog.
So it doesn't matter if you measure from the top of the reference line?
Not really. Well, in this case, you should be measuring south, right? So, like, you put your, as long as you've got your protractor there right at south.
Is that right?
Yeah, that's probably okay. Yeah. It's not ideal, but I'm not gonna,
Huh? Where am I? Now I'm here.
east 75 north. East 75 north.
Wow. That one's 3.5.
East 75 northeast. I guess it should really be like this, shouldn't it? East 75. And it's 3.5 long, so I'm going to draw it to 3.5 right there. And then measure your resultant. Let me just draw it first. So there's your answer. Looks just like that. Let's measure it and see.
He starts from the top and starts from the bottom.
Yeah, it's okay.
Oh,
I got 6.5.
yeah.
6.5 centimeters, or what would that be? 65 kilometers per hour, right?
If you don't change that back on the test, you're gonna lose marks.
Yeah, you really should write it as kilometers per hour. It's important. Yeah. Okay, now where do I measure from? Well, this isn't recycling. Oh yeah, we're going to measure this now, right? Where should I measure from based on what I have here? Measure from south, because you've already got a south line, right? Measure from south. Come on. Where's that rotate thingy? There we go. Okay. I got to go all the way like this. So measure from south, because you've already got it there. Make sure you measure the right one. So it's going to be south all the way to there. It looks like 66. South, 66, east. Now what if you measured from east? Well, then it would be east 10, 20, 24 south, right? Either one of those would get you the mark on the test. Either one. I suggest measure from south because you've already got the reference line. That's all. That's fine.
So if I put 25, is that wrong?
No, plus or minus 3, right?
Oh.
Plus or minus 3. All good, makes sense. Now's the time to ask.
Looks good to me.
south. 10, 20, 30, 40, 50, 66. East. Okay, now on your sheet, I think it says there's a couple of additional practice ones there, right? And they're numbered 1 and 2 because I'm still in the process of redoing my sort of lessons here. They're actually, the solutions are attached with the numbers 3 and 4, that's all. Okay, so on that solution page that's on the back there, you can just scratch out questions number 1 and 2. Right here, that's got to go away, Willie. If you're going to be successful in here, that's got to go away. Simple as that. Scratch out questions 1 and 2. The solutions here, the answers, solutions, are for those practice ones right there.
So this 1 and 2 on answer.
Okay? Because I have to just put that all together properly. Okay, I want to know, can you do all this? So here you go. Little quiz around. Not for marks, but you're going to hand it in before you leave today. I want to know, can you do it? I strongly urge you to do it on your own. So that I can tell who can do what. Okay? Not for marks. Clearly, this is just, can you do it? Do I need to spend more time with people? Who knows how to do it? Who doesn't know how?
I don't know how to do that.
Okay? You got three questions. That's it. Very simple. Some of you will finish in no time. Go.